Before I start this video about the notes for transformations, let's take a look at the future and see how you're going to be asked this question on the STAR. This is from a STAR test from a year or two or three ago, and they asked it towards the end of the test when you're already tired. They said, the linear parent function is graphed here. Okay, so if it's the parent function, that means y is equal to x. Here is a new function called h. It's going to be the negative of f of x plus 3. In the last days of notes, I showed you how to do this plus 3, and this negative f of x should be a really easy thing to do. Okay, so we're just going to use some substitution. This right here is f of x. All of that whole graph, that's f of x, that line. F of x is the parent, so it's just equal to x. If we're going to make a new function called h of x, they said it's equal to the negative version of f of x. And let me erase this, erase. What is f of x? What is just this equal to? That is all equal to x. So we're going to substitute. Instead of writing f, we're going to write what f is equal to, which is x. So we have the negative sign that we copied, because that was already in the equation right there. We're going to copy x, and then we're going to add 3 to it. Okay. Since we're pretty awesome at graphing, let's just do this graph really easily. We can see that the new y-intercept, b, is going to be 3, and we're just going to have a negative slope of 1. So we're going to put a dot at 3, and then we're going to have a slope of negative 1. So starting from there, we're just going to go down by 1s each time. So let's just connect those dots with a line, and we'll already be at our answer. That wasn't so bad. It was going to give you the graphs below, but I cut them all out because it's too easy. Graphing is easy, and you've practiced a lot. Now let's talk about what exactly I did and how can you do the same thing. We're on the second day of linear function transformations. That R is a little bit weird, but sometimes being weird is okay. The most basic graph you can have is y equals x. If you ever have a graph that has y equals 3x, what's the difference between these two things? Well, this one is the same thing, but times 3. It's the same exact equation. Everything's the same, except we're multiplying by 3. So let's write that in function form. F of x equals x. The second equation is y equals 3x. If we already used f of x, we can't use the same function twice. That was something that we kind of left out in the last video, is that we didn't say it, but I was thinking it the whole time, that if f of x is equal to x, then whenever we change f of x, we need to call it something different. So g is the next letter after f, so this next function is going to be called g of x. This one is going to be 3 times f of x. Alright, so let's just look to the left. Y equals x and y equals 3x. The only difference is the bottom one is 3 times the first one. Let's look over here. F of x equals x, and g of x equals 3 times f of x. The only difference took f well, there's actually a name for whenever you multiply like this. That was actually a scale factor. We multiplied by a scale factor of 3. Because we took everything in f of x, every little number that was on that line, we're going to multiply every x by 3, and that's going to make our new graph called g. So this right here is called a scale factor. Let me change my ink. It's too fat. Or maybe I'm too zoomed in. That's a scale factor. And what a scale factor does is it multiplies to enlarge or reduce numbers. That's all that scale factors do. They multiply, and once they multiply, they're either going to make something grow larger or it's going to make something shrink. In this case, since f of x was so simple, all that it did was, okay, let's graph it and find out. Please draw this graph in your journal. We have the x-axis, we have the y-axis. It's going to be a really simple graph. We're going to make one line for f. F is the parent. This is just f of x equals x. Then the new function is g, which is going to be 3 times f of x. So all that means is for any point that's on f, like 1, 1, g is going to be 3 higher for its y. And every other point on f would also be 3 times greater on g. Every y on g is going to be 3 times greater than a y on f for the same x. Let's look at that in a table form. We have x's, we have f of x, and we're going to have g of x. We plug in our same normal x's, 0, 1, 2. F of x is going to be equal to x. So whatever you picked for x, that's what f of x will be too. G of x is equal to 3 times f of x. So that means we are going to look at every number we put for f of x, and to get g, we're just going to multiply them all by 3. So 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6. And that's how a transformation could look in a table. That's one of the ways it could look. Let's start again, but this time let's start from a graph. The purple line is going to be f of x, and we're going to make a new line called g, and what that one's going to do is it's going to take everything on f of x, and we're going to do a minus 3. So let's get some points from f. We have 0, 2, 3, 4, and negative 3, 0. Let's put that in a table. X, f of x, g of x. Our numbers are negative 3 for x, 0, and 3. And when we put those numbers for x, what was our output on f? Our output for f was 0, 2, and 4. G of x is all of f. Any output that you get for f, you're going to subtract 3 from it. So then we'll just do 0 minus 3, 2 minus 3, 4 minus 3. And that's going to give us negative 3, negative 1, 1. So let's put those new dots in a different color, and that's going to give us the graph of g. Negative 3, negative 1, and 1. So negative 3, negative 3. Let's see, we were counting by 2's. I'll use blue. Negative 3, negative 3. 0, negative 1. And 3 goes with 1. Okay, so what's the only difference between these two lines? Is it the slope? Is it the y-intercept? Are they parallel? The answer to the first question is no. The answer to the next two questions is yes. The change was in the y-intercept. All that happened was we took every single one of these numbers for x. I only picked the easy ones, but you could have picked any number that was on f, and we just subtracted 3. But we did that to the y. We didn't do it to x. We kept the x the same, but we changed the y by 3. So let's write that down. When transforming functions, adding or subtracting any function by a constant at the end, like if it's not inside of any of the parentheses, if that minus 3, or if we changed it and made a plus 5 instead of a minus 3, if that's happening outside of the function, you're going to shift the graph up or down. And that's going to be called a vertical shift. A vertical shift is whenever you have a new function, and that new function just takes the old function and adds or subtracts a constant. That plus or minus means it's either going to add or subtract. Okay, so let's see what else we can do to a function. What about right here? Here, we multiplied by something, by a scale factor, and the scale factor changed the slope. But that's because we had a really easy equation. So let's see what happens if we have a more complicated equation and we multiply by a scale factor. Alright, so I copied and pasted the same f of x. We never found the equation for it. Oh, let me move it a little bit. There. Now it's right on the line. We never found the equation for f of x, but let's make a new function called g of x. And that one's going to be equal to, okay, we'll use a different letter. G, H. H is next in the alphabet. H of x will be 2 times f of x. So let's see. Is that only going to change the slope, or is it going to change more than just the slope? Place your bets. What do you think is going to happen? Think about it, and now let's find out. Let's go ahead and do it with the table, and then we'll do it with the equation afterwards. We have x and f of x and g of x. The numbers that we use for f that are easy to read are the same ones from before. Negative 3, 0, 3, 4. Whenever you're writing a number that's on a graph, you always need to put the parentheses for that ordered pair. We had negative 3, 0, 0, 2, and 3, 4. What was the equation for g of x? G of x, oh, we're not using g, we're using h. H of x is equal to twice of f of x. So let's do 0 times 2. We're taking everything from this column here. I use a different color. We're taking things from f, and that's what we're going to be multiplying by 2. So 0 times 2, 2 times 2, 4 times 2. We get 0, 4, 8. And what was our x? Our x was negative 3, 0, and 3. Negative 3 is still at 0. 0 is with 4. Okay, so it looks like we're just doubling right there, but let's see what happens here. 3 is with 8. 8. Let's connect these with a line. And there we go. Now let's look at it. And let's look at the question we were supposed to answer. Will the scale factor change the slope or the y-intercept? The slope means the steepness. Okay. Since this line is not parallel, the slope had to have changed. And look at the y-intercepts. The y-intercept was at 2, and then it moved to 4. But this point stayed the same. Negative 3, 0 stayed the same. The x-intercept stayed the same for some reason. So let's look at the equations and see what actually changed. To find the equations, we need to find the slope. So let's find the m for f of x. Let's do 4 minus 2 divided by 3 minus 0 to get 2 over 3. That was the slope of f, and the b for f was 2. Okay, so let me go right below this graph. F of x, the equation for that was the slope 2/3 times x plus 2. Let me fix that 3 to make it look a little more neat. Then we had the orange line, h of x. And h of x, some points on it were 3, 8, and 0, 4. So let's find that new slope. M equals 8 minus 4 over 3 minus 0, which leaves 4 over 3. 4 over 3. H of x equals 4 over 3 times x, because that's the slope, and then the y-intercept is 4. So what's the difference between these two equations? What changed? Let's look at the top of those fractions. The 2 changed to a 4 for the slope, but the bottom stayed the same. So this was a times 2, and this was also a times 2. So that means we took everything, each part, and multiplied by 2. That's what happened. And let's see if we can write that a little bit neater than with all these arrows. So h of x was equal to, we took everything on f, I'll write it in purple, 2/3 x plus 2. To get h, we took everything from f and we multiplied it all by 2. Does that look familiar? That's what this said we were going to do. That's what the rule at the start said. This was just a lot more neat. This says we took everything on f and we multiplied it by a factor of 2. These equations, they were the long way of doing it, but that's how you would say h of x equals twice f of x.